તમને દી દાદા એવું કહે છે. હા. Good morning, everyone. Can you all hear me now? And hopefully you can see the screen as well, right? Okay, let's start. So here is this question number 9, right? Okay, so did you have a chemistry class? Is that why people are coming in now? Okay, fine. Right. So it is given that a projectile is thrown from ground and it is falling on the ground, right? And the range is 3 times the maximum height. Okay, first of all, tell me, has anyone done this question? Tell me your answer. Have you got an answer? If yes, what's your answer? Okay, very good, Ankita. Jaikit, what is your answer when you write Nandini? Okay. Dikshita, are you sure about your calculation? N is 45. No, N can't be 60. No, Patel, Nandini, I don't think it's going to be 15. Arey, atla બધા લોકો. Okay, you're all getting different answers, right? Okay, no problem though, right? Only one answer may be right. Okay, everyone getting different answers. Everyone cannot be right. There's a lot of disagreement. Okay, let's see. So it is given in the question that range is equal to 3 times the maximum height. So first of all, we are using formula, right? Range is equal to 3 times the maximum height. I hope people, you all are not guessing answers. કારણ કે સોલ્વ કર્યા વગર ગમે તે આન્સર આપતા નહીં. ભલે ખોટું સોલ્વ કર્યું હોય કઈ વાંધો નહીં. It's okay. We can be wrong sometimes. Okay, so R, range formula, right? I hope everyone remembers the range formula. It is V0 square, 2V0 square sine theta 0 cos theta 0 divided by 2G. That is range. Now 3 into maximum height formula is V0 square sine square theta 0 by, no, sorry, right? This is what we have. Okay, I made a mistake with the range formula. I corrected it. All right, so this is range and this is 3 into maximum height. Right, now we are going to simplify this. We'll cancel whatever we can cancel, right? Okay, we'll cancel a lot of things here. So G is obviously cancelled. V0 square is cancelled. 1 sine theta will get cancelled. Okay, that's it. So we are now going to get, we will now get tan theta on this side, right, is equal to 4 by 3, right? 2 into 2, 4, and divided by 3, right? So tan theta is equal to 4 by 3. This is clearly means, this clearly meaning here that theta 0 should be equal to 53 degree, right? I hope all of you remember that. Okay, so now it is given in question, that this angle of projection matlab theta 0, right? The angle of projection, angle with which it was thrown, right, that is 45 plus n. So if you compare both sides, clearly n is equal to 8. So congratulations people who got it 8, right? Well done. Okay, I hope to everyone the method was clear. Okay, now I think we are on to the last question. Yeah, that was easy. ના હજી એક હતો ને, ટેક્સ્ટ બુકમાંથી આપ્યો હતો, 11th હતો એ. Okay, so this is question number 10 here. It says a large number of bullets are fired in every direction, every possible direction, right? What is the maximum area on which these bullets will spread on the ground, right? Okay, so let's see how to solve this question. See, let's say this is from where the gun is firing the bullets. So at different angles, see, it is given that you can throw it at different angles, right, in different directions. Okay, very good. Lots of people are giving me answers. So it would go off and fall like this. But if you change the angle, it's possible that it will fall here, it's possible it will fall here. Like this, it will fall at different places, right? But this is not the only direction in which you can fire. If you watch it, this is side view. If you now watch it from the top, let's say by using a helicopter from a safe distance, okay, top view. So અહીંયા ગન છે એ આમ ફાયર કરે, આમ કરે, આમ કરે, આમ કરે. So do you realize that it will actually make a circle? The where the bullets fall will make a circle, right? And with radius equal to maximum range. Okay, with radius equal to maximum range. All right. So if r max is the radius, then the area of the circle, is going to be pi r max square. So this is your answer. So now you just have to put the value of r max. So that is going to be v0 square by g, right? Oh, sorry. So just a minute, I made a slight mistake in writing here. Okay, so pi v0 square by g whole square. So that is pi into v0 raised to 4 upon g square. All right. So that's the answer. I think that is option B. I don't know. Right? Is that option B? That's what most of the people are saying. Pi, yes. Pi u raised to 4 by g square. Yeah, correct. Okay, so that's how you do it. Now, the next question. I think that was from the book. What was that question? I don't really remember. I gave it from the book. It was number. What number, people? Which number? 16. Okay. 16. Okay, have you done it, people? આ તો ટેક્સ્ટબુક નો ક્વેશ્ચન છે, કદાચ મારે કરાવવો ન પડે એવું બને. Have you done it? How many of you have done it, and what's your answer if you have done it? Okay. I think I should discuss it. ચલો, અલગ અલગ આન્સર્સ આવે છે, right? So I'm going to ask you some basic questions first. Yes, Neil. I'm going to ask you some basic questions. It is given that a cricketer can throw a ball to a maximum horizontal distance. So this is R max, right? It is given. Okay. Now the question is, how high above the ground can the cricketer throw the same ball? જો આન્સર તો બરાબર છે, આન્સર તો ગમે તે નંબર તમે કહી શકો. I want to know reason, so I'm going to ask you, listen to this carefully. If so, what this question means is, if the cricketer tries, how much can he throw the ball up, right? How high? So if you want to throw highest, okay, if you want to throw the ball to largest height, or if you want to throw it highest, at what angle should you throw? At what angle with ground should you throw? પહેલા તો ઈ કહો મને, તમે concept સમજ્યા કે નહીં? At what angle should you throw? People, please participate in the discussion. Come on, everyone. I've got many answers, but many more people are remaining to answer. Okay, I'm calling them, right? Well. Okay, everyone, listen to this carefully. See, suppose I'd be standing here and I want to throw the ball, right? With some given speed. See, my hand or any person's hand have a limitation, right? It's not like you can throw it at any speed you want. There is a limitation. You cannot throw faster than something. So suppose that you can throw the ball with some fixed speed. Suppose you can throw the ball with some fixed initial speed, all right? એનાથી વધુ ન થાય. Like let's say 10 meter per second. Suppose, okay, it's actually very less, but I'm just saying, right? So then if you throw it like this, it will go in this way. But if you throw it vertical, it will go high and fall down. So I hope you realize, everyone, that if you want to throw it highest, if you want to throw the ball highest, then you should throw it at 90-degree with the ground. Is this clear? First of all, if you want to throw the ball highest, then you should throw it at 90-degree with the ground. I'm specifically explaining this because some answers were not right. Okay, so I just want to clarify this, right, everyone? I hope it's fine now, right? Okay, one more thing. I hope this is very clear. Now look at the question again. It says that cricketer can throw a ball to a maximum horizontal range of 100 meters. So if you want to throw the ball to maximum range or maximum horizontal distance, then for that what should be the angle? For that, what should be the angle for maximum range or for maximum horizontal distance? 45. Very good. So you should understand, everyone, that this question is actually talking about two different cases. Case 1, where the ball is thrown at an angle 45 degree and we get maximum range equal to 100. Okay, but then there is second case where this cricketer is trying to throw highest. Okay, trying to throw high. Okay, so in that case, obviously throwing at 45 degree will be wrong. Okay, this is stupid. The cricketer should throw it at 90 degree. All right, so these are two different cases, right? But what will remain same? The person and the ball are same, right? Okay, so that's why V0, that is initial speed, will be fixed, right? Okay, initial speed will be fixed. So here what we'll do is, from case 1, we will find out initial speed. So we will use Rmax formula. Okay, you use Rmax formula. I'm leaving it to you. People, I'm leaving calculations to you. તમારે કરવાનું છે, હું ખાલી તમને કહી દઉં. So you will be able to find V0. Okay, done. આટલું લખી લેજો જેને નો ફાવ્યું હોય. Okay. Now this is V0. Once you get V0, you put it in this case 2 to find maximum height. But don't forget, this time theta 0 is 90, right? This time theta 0 is 90. Don't forget that, because the cricketer would be throwing the ball straight up like this. Okay, method clear, everyone? Okay, Nandini, I'll see what can be done, right? Okay, then, so this is what we have, right? Now, that's it for this question, right? Now let's go to the next topic. હજી projectile motion જ ચાલશે, right? There is one final thing that I have to tell you about projectile motion, and that is equation of trajectory or path. Trajectory means path, right? See, according to maths, every kind of, for every kind of shape, for maybe like this, or maybe this, or even for this, right? For all such shapes, we have equations, right? In 9th standard and 10th standard, you have studied linear equations. Those are such that the shape of the graph would be a straight line, right? Ankita, I'm not so sure I understand what you're trying to say. Linear equation would mean that this graph, when you draw a graph of equation like this, ax plus by plus c equal to 0, you get a straight line. Okay, so like that, every shape, for every shape we can find some kind of equation, right? So I'm sure you all remember that when a body is thrown and it's doing projectile motion, right? Okay, again, from here to here, maybe like this, right? So this makes a parabola. That's what we have already talked about, right? This makes a parabola. Then what is the equation of this path, right? Okay, yes, Nandini, you are right. 90 degrees is a special case. We'll talk about that, right? So if you want to make an equation for this trajectory or this path, right? So how to do it? Now, see, this method is general. We are doing we are doing it for parabola. Sorry, for projectile motion. We are doing it for projectile motion, but the method is general, right? Whenever you want to find equation of trajectory, right? Whenever you want to find equation of trajectory of anything, parabol, for a projectile, for a football, for a missile, anything, doesn't matter, right? Again, trajectory means path, right? So whenever you want to find equation of the path or trajectory, you always do this. You substitute means put value of t from either delta x into delta y or from delta y into delta x. આવી રીતે જ કરવાનું હોય, simple. Okay, I hope you understood what I'm saying. You substitute or put the value of t એટલે time interval, right, from either delta x into delta y or from delta y into delta x, right? આવું કરો એટલે આવી જ જાય, right? Okay, so let's start here. So what are the equations that we have got for projectile motion? First of all, for delta x, we have got v0 cos theta 0 t. And for delta y, we have got v0 sin theta 0 t minus 1 by 2 gt square, right? So follow what I said here. We will take the value of t, right? And from delta x, we'll put it into delta y. Bus, પૂરું થઈ ગયું. Okay? right? Because here this is easier. The first equation with delta x is easier. The second equation is slightly complicated, so we will not use the second one. Formula for projectile, for projectile there is no formula. Think about it. I, Nandini, it's still not clear what you're trying to say actually. Formulas for projectile and trajectory path are same. People, ટ્રેજેક્ટરી પાથ એટલે કોઈ વસ્તુ નથી. ટ્રેજેક્ટરી પાથ કોને કહેવાય? આ પ્રોજેક્ટાઇલ છે, પ્રોજેક્ટાઇલ આમ જાય છે. ઓકે, so we are talking about projectile motion only. This is projectile motion, right? Trajectory path તો આ shape છે. Okay, this shape, which shape? The parabola shape, that is called path, right? Path એટલે જેની ઉપર આ ચાલે, આમ જાય આમ જાય આમ જાય આમ જાય આમ જાય એવી રીતે. Okay, so we are still studying projectile motion only. So when we will substitute the value of t from this into this, right? When we will substitute the value of t from this equation into here, what will happen is there will be no t, right? In the whole relation there will not be any t. So now after we substitute, after we put this value here, we'll get a equation where there is delta x and delta y, right? So let's do that. So putting this value in 2, putting this value in number 2, what do we get? Delta y is equal to v0 sine theta 0. Now instead of t, what should I write? Delta x by v0 cos theta 0 minus 1 by 2 g t square, right? So this is what we have got. Okay, now we will simplify this. બહુ easy છે simplify કરવું તો. So v0 is cancelled. So delta x sin theta 0 upon cos theta 0 means tan theta 0. Yes, Saurabh, you were right. Minus 1 by 2 g. Over here this is very easy. Delta x squared divided by v0 square cos square theta 0. So this is the equation that we have got, right? Okay, now I would say that this is actually an important formula to remember. And આ છે ને એક શોર્ટકટ જેવું છે. It helps you find answers very fast, right? It helps you find lots of answers very quickly. Okay, so this equation is called equation of trajectory or path of projectile, right? Okay, so projectile means the thing that you are throwing. તો એ આમ જશે આમ જશે અહીંયા જશે આમ. તો આ જે શેપ બનાવ્યો એ શેપની શું મેથેમેટિકલ ઇક્વેશન? તો આ ઇક્વેશન, that's what we have derived. Okay, right? So this is how you find equation of trajectory of projectile, right? Clear? Please try to remember this equation. હું મજાક નથી કરતો, મને ખબર છે બહુ મોટી છે, right? So if you should ideally be knowing this. Suppose you don't want to remember, તો આ ડેરિવેશન 5 વાર લખ નાખો એટલે એવું સરસ આવડી જાય કે તમે 1 મિનિટની અંદર કરી શકો, right? You understand what I'm saying? You do this, you put this here and you get this. છે એકદમ easy, right? So it's your choice. Either you remember it or learn to derive. Okay, if you learn to derive, કામ આવશે. એક્ઝામમાં ડેરિવેશન તો આવે જ છે, બરાબર ને? આવું પૂછાય, derive equation of trajectory, 2 marks. Yeah, if you do both, it's best actually. If you do both of these, it's best, right? Now, with this, the topic projectile motion is over, right? Let me tell you how this is useful. Let me tell you how this equation is useful. એના માટે છે ને હું એક homework question નો use કરીશ, right? I gave you so many questions of projectile motion, right? Let's use this one, number 7, right? ના, એના કરતા આ સૌથી એકદમ suitable છે, number 6. It is like nicely made for this formula, right? Okay, એના વગરે થાય, જો આપણે કર્યો જ તો એના વગરે, right? So let's see how you would be doing it. It is given in the question that this is 20 meter, and then we throw something from here at 0 angle and it falls here, આવું છે ને, right? Okay, and this distance is 6, and this is point A, and let's say here's point B. And the question is, first, two questions are there. What is the initial speed? Means speed with which it was thrown. And the second question is, what is the speed at B, right? So these are the two questions. So suppose you use equation of trajectory, જો કેવું easy થાય, right? Downwards negative, upwards positive, આપણે એમ જ લઈએ છીએ. Right side positive, left side negative. So we are going to use the equation of trajectory again for A to B. Wherever you are doing some kind of calculation, you should write the initial point and the final point clearly. Okay, let's start. So delta y is equal to delta x tan theta 0 minus 1 by 2 g delta x square divided by v0 square cos square theta 0. Okay, so this is the equation. Now for A to B, have a look at this carefully. A to B, delta x is plus 6 meter, delta y is minus 20 meter, and it was given in question that this is thrown horizontal. So theta 0 is equal to 0. ખબર કે રીતે પડે કે equation of trajectory use કરવાનું? Good thing. I would say, see, here we know delta y, here we know delta x, and we know the initial angle also, and we want to find v0. So આ બધી વસ્તુ આ equation થી relate થાય, correct? Think about it. Other equations that we have used so far, they are all with time. For example, delta x equal to v0 cos theta 0 t, or delta y equal to v0 sin theta 0 t minus 1 by 2 gt square, like that. Okay, why can't we find by circumference formula? What nonsense, Vedant. What does this have to do with circumference? This is not a semicircle, or this is not a quarter circle. Okay, so let's put values. Delta y minus 20 is equal to delta x 6 tan 0 minus 1 by 2. Suppose you take g as 10, delta x square, 6 square 36, v0 square don't know, cos 0, cos square 0 actually, right? So now tan 0 is 0. Here you can do some calculations. This is 18, so this is 180 by v0 square. All right, this is 180 by v0 square. And now if you just simplify this, so you get v0 square is equal to 180 by 20, correct? આમ જાય બધું થઈ ગયું. So this is equal to 9, and tada, you got v0 equal to 3 meter per second. All right, so we have got, right? I'm not saying this has to be easier or anything, right? But equation of trajectory helps helps when you are not interested in knowing time or time interval. Think about it. આમાં t છે જ નહીં ને, right? So wherever you don't want to know the time or not given, then you could use this, right? It helps. ઓલા third equation of kinematics જેવું છે, એમાંય time નતો તો થઈ જતું હતું, right? So like this we get the answer, right? Of course earlier we have done it by this method. If you have your notes, you would have written it, right? That first we put this is equal to 6 and then we found t, right? And based on that we were able to find v0, right? We did that. Okay, so it's not like a big problem, right? But this is a shorter way. Now finally let me just remind you of what tools, what formula we have for projectile motion. It is the same. અરે ખરેખર તો ડેરિવેશન તો સેમ જ છે, રાઈટ? કારણ કે ફિઝિક્સમાં અત્યાર સુધી આ બધું ભણ્યા, ઓલ ધીસ કમ્સ ફ્રોમ 3 ઇક્વેશન્સ ઓફ કાઇનેમેટિક્સ, રાઈટ? એટલે અલ્ટિમેટલી તો બધું એકનું એક જ છે, however you do it, રાઈટ? હું તો 11th ભણતો હતો ને તો મને બરાબર યાદ છે કે પ્રોજેક્ટાઇલ મોશનમાં પહેલા મને એવું લાગતું હતું કે આ બધું કેટલું બધું યાદ રાખવાનું. Okay, I used to think there's so much to remember. It was a big burden. Then I realized that ultimately if you just remember the 3 equations of kinematics, બધું થઈ જાય, right? Ultimately just remember the 3 equations and everything can be done, everything, right? Gracie, tan 0 is 0. Okay, right? Now see, we have following formulas: range, time of flight, maximum height, time to get maximum height, and r max. Okay, આ બધી ફોર્મ્યુલા જે છે ને, v0 સ્ક્વેર sin 2 theta 0 by g, 2v0 sin theta 0 by g, or this one is 2v0x, v0y, આ બધું. Okay, all these formula again they're only valid from ground to ground. Don't forget that. On the other hand, there are some formulas that are true for all kinds of projectile. Okay, true for all kinds of projectile. Which formulas are true for all kind of projectile? Well, here are these. Delta, આ બધું બધા માટે સાચું છે. v0x is v0 cos theta 0, ax is 0, v0y is v0 sin theta 0, ay is minus g, પછી vx is equal to v0 cos theta 0, it's a constant, right? That is because acceleration is 0 in x-axis, but vy is equal to v0 sin theta 0 minus gt, right? Okay, then delta x is v0 cos theta 0 t, delta y is v0 sin theta 0 t minus 1 by 2 gt square, and finally equation of trajectory, which is delta y equal to delta x tan theta 0 minus 1 by 2 g delta x square divided by v0 square cos square theta 0, right? આ રાઈટ સાઈડમાં બધું લખ્યું ને, this is always true. Okay, right સાઈડમાં જે લખ્યું, all that is always true for a projectile, right? But these things on left side, they are only true, these formula are only true for ground to ground. એટલે આ ખાસ રાખજો. Yeah, બરાબર? What I mean to say is the things on the right side are superior, right? Why are they superior? કારણ કે ક્વેશ્ચન આવો પૂછશે ને તો બધાને આવડશે. આ તો બધાને આવડે, બરાબર ને? પણ ક્વેશ્ચન આવો પૂછે તો એટલે અહીંયા સ્ટ્રેટ નો જાય, of course, but like this, right? I hope you understood what I'm saying. So for these kind of situations you need to know all these formula, right? અને આ બધું ગોખવાનું કઈ નથી આમાં. I hope all of you understand. અહીંથી અહીંયા તો બધું equation of kinematics જ છે, right? Okay, fine. So that's it. I will not send you this. I hope you have written it along with me. Okay, પહેલાય અમુક વસ્તુ લખાવેલી છે. This is just to remind you. Okay. Now, relative velocity. Okay, like I said in the last chapter we did not cover this. Why? It wasn't necessary. બે ચેપ્ટરમાં સેમ જ છે, right? And as you can see, we don't even need to talk about it till this moment. Okay, so what is relative velocity? So before we can get started with this, I just like to remind all of you that the observer, right, has some frame of reference. I hope you remember that observer might be sitting in a vehicle, observer might be on a train, right? Okay, observer might be on a train or something else. So observer would have a frame of reference, right? The situation or the position or location from where the observer observes, that is called frame of reference. એવું બધું આવ્યું હતું. There are three things, right? Okay, એ બધું વાંચી લેજો એકવાર જો ભૂલી ગયા હોય તો. Now, why am I bringing this up here? Because there is one very short but amazing sentence. This one. Motion is relative. Okay, motion is relative. This is like, unwritten laws of nature. Okay, so what is meaning of this sentence, right? I would like to explain this by giving an example. I'm not so sure I would have mentioned it. I think I did, but now you'll know better. Suppose there's a tree, right? Okay, and a man is standing next to it, and you are, let's say this is a road, okay, and this is on the side of the road, and this is a vehicle, and you are in the vehicle. So let's call this observer A, and let's call this observer B. So for observer A, tree will be moving, correct? And in which direction? Suppose you say that this is east and this is west, right? Then for observer A, the tree is moving west. Yeah, okay, I said this, right? So wait, I'll just repeat it very quickly. So for observer B, the tree is stationary, right? For observer B, the tree is stationary, right? એટલે જો આની પરથી શું થાય, depending on where you are observing from, you sense motion. And it's even more weird. Suppose there was a vehicle here and it's moving in this direction and there is a person C in it. For that person, for the observer C, the tree is moving in east direction. All right? So what you can clearly understand is that motion depends on who's observing, right? એકને એવું લાગે છે કે tree is not moving, એકને એવું લાગે tree is moving west, એકને એવું લાગે tree is moving east. So everything about motion, I repeat, everything about motion is relative. Okay, relative means when different people see or different observers see, they might see different, right? So what is relative? Number one, position is relative. Number two, displacement is relative, right? Okay, now by default, right? By default, if position and displacement are relative, that means velocity, speed, both are relative. Number 4, acceleration is also relative. Acceleration is also relative. Okay, so all these things about motion are relative. અને એક બહુ ખતરનાક વસ્તુ કહું, તમારા સિલેબસમાં નથી. અકોર્ડિંગ ટુ આઇન્સ્ટાઇન, એન્ડ હી વોઝ રાઇટ, according to Einstein, time is also relative. But we don't have to go that far, right? એટલું બધું અઘરું ફિઝિક્સ તમારે ભણવાનું નથી. Okay, these 4 things are good enough, all right, for you at this stage. That position, displacement, velocity, speed, acceleration, these things are relative. ઓકે, એનો મતલબ અલગ અલગ લોકો જોશે ને તો અલગ અલગ દેખાઈ શકે બેઝડ ઓન ધેર ફ્રેમ ઓફ રેફરન્સ. Based on their frame of reference. Okay, right? See, a very good example of this can be seen on the roads. Now let me just start to you know uh, let me just start to make you all think in a very intuitive way. તમને ખબર જ છે આવું બધું, right? You know all this, right? Okay, now it's time to put it in form of maths. Let's see. So suppose you are in this vehicle, which is, let's say, speeding on a highway at speed 80 kilometer per hour. Okay, not breaking speed limit. And have you noted that if you see the vehicles that are coming from opposite side, they appear to be so fast? Yes or no? Have you noted that? If you watch vehicles coming from the opposite side, they appear to be very fast. Right? Okay. So, and it would be difficult. It would be difficult to see sometimes. I mean, if the speed is quite high, right? So if you're trying to see who's in there, it's quite tough to see, right? But if you consider a vehicle which is moving in front of you, right, then normally it's quite easy to count and to see who's in there, right, what they're doing. So this is because here both vehicles are moving in the same direction, right? So with respect to the observer A, or relative to observer A, right, this car, let's call this car, okay, car has less velocity or less speed, okay, the yellow car, right? But suppose, let's say that suppose this was a truck. Even in that case the truck would appear to be moving fast, right? Because it's coming from the opposite side, right? So what is going on over here, right? That's what we are going to talk about. Okay, so suppose, first of all, in 1D, right, one dimension, motion in one dimension, right? Interaction time, what is meaning of interaction time? So let's say that there is a point here, particle, okay, let's say there is a particle B, right? Let's say there is a particle, ના આને A રાખો, ચલો અહીંયા A, આ બરાબર. And here is a particle B, okay, this is positive side, this is negative side, okay, and suppose here is origin O, 0, all right. So suppose a person is standing, okay, on the ground, or at this point O, fixed, right, not moving. But this is a particle B, or maybe an ant or some insect, right, that can see, okay, this is moving, and this is also moving. So do you see that at some point of time this position is xb, xb, that is position of b, right? And at the same point of time, this is xa, that is position of a, right? Okay, so now if you think that suppose b is also seeing a, suppose b is seeing a, right? A b એટલે કોઈ particle કે કોઈ પણ છે, right, which can see, let's say, right? So then b would see that a is at this much distance in front or on the right side. Okay, right? So this we call distance of b as measured by a, or position of b as measured by a, xba. પછી હમણાં symbols નો meaning લખાવું. Okay, right? Why we write it like that, that will also be clear. So do you clearly understand that by geometry we have this? Yes or no? People, yes or no? By simple geometry we have this. Okay, so xba is equal to xa minus xb, right? So now if I want to find velocity of a, then I'll have to do differentiation of position, correct? But whose position? Of a's position. Is this clear? Right? So this would mean, just like this, if I would do velocity of b, then that would be vb, that would be dxb by dt, right? So if I'll do differentiation of this equation, આખી વસ્તુનું differentiation કરનાર, right? So by using subtraction rule, this is what we get, right? So now this is clearly va minus vb, right? This is clearly va minus vb. Now what is on the left side? Okay, what is there on the left side is very interesting to understand. xba means position of, oh no, I made such a horrible mistake with the symbol, I'm so sorry. Arey yaar. This is supposed to be xab, I'm so sorry. Please change it, everyone, please change it. Make sure you change it. Did everyone change it? નહીતર બહુ જ લોચો થઈ જશે હો. Take it seriously, everyone, please change it. How could I make this horrible mistake? Okay, અત્યારે લખતી વખતે મારું અચાનક ધ્યાન પડ્યું. Here also please change it. No, it is not okay, this is very bad. All right, changed it, everyone? Yes, Ami. So now this is xab, right? This is supposed to be xab. So okay, all right. So what is meaning of the symbol xab? It means position of a as seen or observed by b, right? It is position of a as seen or observed by b. So what does this mean? If imagine this were you, right, then you might be saying something like, okay, a is 10 meters in front of me, right? Then both would move, right? It is possible that both are moving, right? This is also moving, I mean b is moving, a is moving, right? Then the distance between them could also change, right? If a is fast, the distance will increase, right? Okay, so like that. the distances could change. So that's why what B is observing, B is observing A. So B is continuously noting how much ahead is A, right? Like that. So position of A as seen or observed by B is written as XAB. So if I do differentiation of a position, if I do differentiation of a position, we'll get velocity. So this symbol now means what does VAB mean? It means velocity of A as observed by B, right? It means velocity of A as observed by B, right? Okay, is the maths clear till this equation? Again, it's just what we have learned earlier. Differentiation differentiation of position of A is velocity of A, differentiation of position of B is velocity of B. So here B is observing A, so that is the position of A as observed by B. So if you do its differentiation, you get VAB. Yeah, I will talk about that, right? Just a minute, right? So this is velocity of A as seen or observed by B. It is also written like this, okay? It is also written as this: velocity of A with respect to. With respect to means compared to. Okay, velocity of A with respect to B. Right? This is also velocity of A with respect to B. Okay. Right? So what does this mean? Let's take meaning out of this equation, okay, in the remaining 5 minutes. Have a look. Suppose you are on a straight highway, right? Let's say this is U, right? Let's call you B. Okay, and this is another vehicle, and let's say this vehicle, inside the vehicle, or let's call this vehicle itself as A, right? Let's call this vehicle itself as A, right? And I'm sure you have seen that every vehicle has a speedometer, right? You have seen that every vehicle has a speedometer. So let's say A speedometer is showing 60 kilometer per hour, okay, right? And B's speedometer, that is the vehicle in which you are, okay, that speedometer is showing 40 kilometer per hour, right? And let's say this vehicle B in which you are sitting is also going in the same direction, right? Okay, so what we have derived is, what we have derived is velocity of A as seen by B, velocity of A as seen by B is equal to velocity of A minus velocity of B. See, it's velocity, not speed, right? A one dimension motion માં vector sign નથી કરી, but we will do that soon. Remember, these are velocities. So right side positive. So A's velocity is actually 60, right? And B's velocity is 40. So what that means is, by sitting in this vehicle, you are observing, B is observing that the vehicle A is moving at a speed of or velocity of 20 kilometer per hour. Okay, moving with a velocity of 20 kilometer per hour. એટલે slow દેખાય. I hope you understand what I'm saying. એટલે slow દેખાય. Right? Suppose there was a vehicle C that was moving like this, and C's speedometer was showing 50 kilometer per hour. No, Devya, that is wrong. velocities, again these are velocities, everyone. Okay, everyone, these are velocities. So if you are now over here in D and observing C, so velocity of C as observed by B, velocity of C as observed by B is equal to velocity of C minus velocity of B. Now this is where you have to be very careful. Velocity of C is minus 50. Is that clear, everyone? Why am I writing minus 50? Is that clear? Minus 50. Velocity of C is minus 50. Is that clear? અરે ઓપોઝિટ નહીં, લેફ્ટ ડાયરેક્શન, લેફ્ટ ઓપોઝિટ ની વાત નથી. ઓકે, માઇનસ VB, velocity of B, velocity of B is 40 kilometer per hour, right? So now this gives you minus 90. So what does this mean? It means that if you are sitting here in this vehicle, તમને એવું દેખાશે કે આ કાર છે ને આ સી 90 કિલોમીટર પર આવરની સ્પીડે આવે છે. સ્પીડ 90, વેલોસિટી minus 90. પીપલ પ્લીઝ નોટિસ, વેલોસિટી minus 90, સ્પીડ 90. તો તમને આ બહુ ફાસ્ટ દેખાશે, but this will appear to be slow, right? And this appears to be fast. Is this clear, everyone? Right? Let's take another case of the same. Okay, suppose there was one more vehicle D, right? આવું કોક વાર ઓવરટેક કરતી વખતે થાય. Suppose there is one more vehicle D going towards right side, and D's speedometer also shows 40 kilometer per hour. Very good, Falak, you have understood that. Suppose D's speedometer is also showing 40 kilometer per hour, all right, and D is also going with you. Then what do you think will happen? If you are watching from B, you're B, so you're watching D from B, right? What do you think this will be? Come on, can you find it quickly? Hurry up, come on, hurry up. Let me show you the diagram. Here. Yes, it will. બહુ ઓછા લોકોએ આન્સર આપ્યો યાર, કેમ આવું? હે, આ તો એકદમ ઇન્ટ્યુટિવ જેવું હતું. વાંધો નહીં, હવે તમને I can't do anything over here, right? Maybe you are calculating. VD minus VB, right? That's what you have to do. VD minus VB, and both are plus 40, isn't it? Because both are going towards the right side, so both are 40. Okay, so this would mean it would be 0. So I'm sure you would have noticed this also. કોક વાર છે ને જતા હોય ને આપણે, અને આમ કોક આપણને બાજુમાંથી ઓવરટેક કરવા જતું હોય ને પછી બેની સ્પીડ સેમ થઈ જાય ને તો એવું લાગે કે આ હરે હરે જ આવે છે, right? It doesn't appear to be moving at all. ખાલી ટાયર ફરે એ દેખાય, that's it, right? But it's as if you can even hold hands. ઘણા લોકો એવા સ્ટન્ટ કરતા હોય છે. I know some of you would have tried that. So when these two velocities are equal, right? When these two velocities are equal, both imagine nahi, both observe, Ashish, right? All this is not imagination, remember. Let me tell you that, everyone. આ તમારું ઇમેજિનેશન નથી કે આ કાર ફાસ્ટ છે ને આ સ્લો છે. નો, this is reality. If you see it like this, if you see it from this vehicle, this C will appear fast compared to this. Okay, this C will appear fast compared to A. Okay, so you should not forget this. Even trees are not stationary. Is tree stationary? No way. If you watch it from space, let's say this is Earth and you're watching from space, then this tree is moving with the Earth at a speed of 30 kilometer per second. With a speed of 30 kilometer per second, this tree is not stationary. So it's all about observer, right? It is all about observer. Observer અહીંયા છાયામાં ઉભો રહી ગયો, ઓબ્ઝર્વર અહીંયા છાયામાં ઉભો રહી ગયો તો ટ્રી સ્ટેશનરી. ઓબ્ઝર્વર સ્પેસમાં જતો રહ્યો એસ્ટ્રોનોટ, then tree is moving with a speed 30 kilometer per second, right? Okay, so it's all about the observer, right? So goodbye everyone, we'll stop this class here, right? Tomorrow we will solve more questions related to this. Okay, so please think about relative motion, everyone. Yeah, no homework today.